So we're just after lunch. You didn't know you needed to see a Victorian squirrel diorama. Now you do. A lot of the storyline here is about balancing things. So here, kind of a classical economy and environment. But there's a lot of other things we balance. We started touching on those in the conversations this morning. Emotion and logic. How do we harness the passion of people while managing their biases? And a lot of the biases, both value judgments, but just cognitive biases. Things like confirmation bias, things like status quo bias that gets reinforced by confirmation bias. How do we avoid some of those trappings? How do we take what is a nuanced and complex answer, if you will, from science and fit it into a pragmatic policy paradigm? How do we simplify without losing too much of the nuance? And then how do we manage for uncertainty and risk? How do we balance these things as we move forward? A really brief, Ontario, diverse, temperate climate in the east, getting to a continental climate in the middle, variety of different forest ecosystems, same across most of Canada, variety of different land use tenures, overlapping indigenous claims, treaties, etc. Divided up into 41 forest management units for management purposes. The average million hectares in size, the biggest one's about 2 million. And that swath across the middle, that's mostly what I'm talking about. The area of the undertaking where we have environmental assessment coverage. Not the far north, not the settled landscape in the south. We have a bunch of regulations, legislation, etc. The most pertinent being the Crown Forest Sustainability Act. This is where we lay out this idea of our target is large, healthy, diverse forests. But particularly in here, we entrench in our legislation a need to emulate natural disturbance, as well as a need to balance the achievement of that with a whole bunch of other things. We do that, so we articulate those principles from legislation using forest management guides. What do we mean by large, healthy, diverse? How do we actually act on the ground when we're operating? Key in those guides is this coarse and fine filter concept. The coarse filter largely being EBM, fine filter being when we know we didn't do a good enough job with the coarse filter, or when society values something different. So the fire may have burned through that tree that had the osprey nest in it, but we put a value on the osprey nest and we provide protection. Our journey, really a couple highlights. We started probably like many jurisdictions, featured species approaches. We had 36 forest management guides for waterfowl and bats and other things. Started moving to ecosystem-based management, featured species. A proclamation that if you manage for moose, you'll manage for 70% of the rest. Starting to add in other pieces, so Martin guides looking now at captured older conifer. Eventually getting to a natural disturbance pattern emulation guide, where we add a whole bunch of things that you're probably familiar with. So this presentation, again, is not focusing so much on the details of what's Ontario's rules, it's the lessons learned. We'll look at a couple examples as we go here. And eventually moving to a landscape guide, where it's an evolution past that natural disturbance, pure natural disturbance emulation. And a key point up until this landscape guide, all of these guides were additive. So we were trying to achieve multiple things for multiple guides, multiple philosophical approaches. And one of the first lessons learned in this was you need sometimes to overhaul. You need to make all of the pieces match, make all the concepts match. Otherwise, you're just, you get lost quickly. So how do we develop those guides? How do we come up with the rules? This is not how science gets into policy. This is how caramel gets into the caramel part, if you've never seen it. So when we talk about science, really science as a process, not as a thing, but it's hard not to talk about uncertainty. So doubt is not a pleasant condition, but certainty is absurd. So managing uncertainty, managing risk associated with uncertainty, where you fit on that risk curve is a key part to how we've evolved through, or continue to evolve. We aren't at the end. We haven't solved this problem. If you've never heard of it, the uncertainty monster is a really interesting way of characterizing this. This is a take on, I think, a 2005 paper first. Judith Curry, she's an atmospheric science professor at Georgia Tech. We are guilty of probably all of these. So the first one being hiding. Either hiding it from people if you're the gatekeeper, or hiding yourself from it, pretending it's not there. exorcism, so well, we just need more information, we just need more science, we can solve this if we just really, you're cutting off the head of the hydra and two more pop up. Every question you answer leads to more questions. The goal finally being assimilation of how do you actually incorporate it into your process. So we follow the typical natural resource management approach of adaptive management. So if you think of, again, science as a process, you can take this hypothesis, projection, you can roll it up into the circle of predict, plan, implement, monitor, react. The key point I think here is this nested idea, and we've touched on some of that in the conversation so far, of at the small scale you may have something like leaving structure inside a fire. And as you go into bigger scales, you get into some of the conceptual approaches of, is EBM a thing that you can actually do? Is sustainable resource management a thing you can actually do? Learning something down here may eventually send a signal that you've forgotten to fix something up here. At the same time, learning something down here does not something doesn't work, let's say. It doesn't automatically mean the entire system is broken. It's the context perhaps of one small piece failed down here because we didn't get that piece right. But that piece done better could still validate the entire approach. So thinking about adaptive management in that nested way really helped us think through some of our problems. Who's heard of the precautionary principle? Can we get them higher? I'm always amazed at relatively few numbers in groups that I ask this question to. So there's a couple versions, Wikipedia being not so much a source, but at least a capturing of the zeitgeist. This first one basically saying, unless you're sure nothing bad will happen, don't act. So paralysis. The second one, going back to the original Rio Convention, is you don't have to be sure that harm will happen before you should take reasonable steps to avoid it. So we ascribe to the second one more than the first, conceptually, but also in our conversations. So as we lay this out from the beginning as kind of a values that intergovernment holds and how we would approach discussions, going back to this kind of touch point is often helpful. Getting into the actual direction, how do you solve some of these problems? One thing we've learned is there's a trade-off on complexity and utility. A very scientific graph here. But as you go up the scale of awesomeness, and as you add more complexity, there's, maybe there's a nice little plateau, sweet spot, but eventually you can get too complex with the direction to the point where effectiveness goes down. People start playing numbers games. People stop buying into the concept that you're trying to reach. We learned that in spades, I think, with our natural disturbance pattern emulation guide. A whole bunch of direction on details of block at the block level. We had lots of numbers, lots of subdivisions and precision. We have targets on spacing. We have templates on the size distribution and how you arrange them across the forest. And what we found was, maybe the best analogy would be standardized testing in education. It was the equivalent that people were teaching to the test. So you began to play the numbers game more than, because it was so difficult, began to play the numbers game more than actually achieving the result of the desired. People actually developed some operations research type people in a couple of companies, developed an optimization routine that could take your default harvest pattern and make the minimal amount of adjustments possible to satisfy the requirements. Sometimes less than 5% change to have a massive swing. Another thing we've learned, so solving that one was moving to the landscape guides, where rather than specifying a whole lot of detail about events, how to lay out as a disturbance as an event, describing the landscape that you're trying to achieve, describing the texture you're trying to achieve, so it's through simulation modeling, it's still inspired from disturbance, it's the result of disturbance of what we expect, but it's not trying to actually lay out disturbances. We've also learned that explicit direction is not always needed. This may be uncomfortable for some people. For example, our structural direction for emulating fires, how much in islands and peninsulas, or just in general, of how much structure to leave behind, both individual and particular patches. We don't have to specify all the components of that to achieve that. We've backed off to a level of specifying a minimum, for example, for the patch requirements. And they're describing that minimum as the 25th percentile of what we think would happen in terms of how clean and how burned out we would expect the fire to be. And all of the other things that we're doing on the land base, particularly going back to our legislation, will minimize adverse effects, where you're leaving the buffer around an osprey nest, where you're leaving a reserve view shed or canoe route, for that matter, the areas that we can't harvest economically. We expect those to fill in the higher than 25th percentile, and so far, this is adaptive management as well, so far it's proving true. We don't have to specify the full range of structure we expect to be able to achieve it. We just described before. A few more lessons, kind of bouncing around a bit. Denominators matter. We've had some successes and failures with this. So with wildlife trees, we spread out, so averaging more for larger areas, having great success with that. We didn't have success with the landscape guide. So the landscape guide, we had visions, we planned on ecoregions. So a management unit is 1 to 2 million hectares, ecoregions are 5 to 10 million hectares. We described what we were trying to achieve in a landscape texture and composition of the ecoregion, and we expected to be able to do some apportioning, do some horse trading across different management units. In the end, we were not able to crack that problem despite a lot of trying, and it became a simple calculation of you have 20% of the ecoregion, you will achieve 20% of the ecoregion's target, no questions. Stories still matter. So although we're moving away from featured species, indicator species, umbrella species, whatever paradigm you want to put in, selling this in terms of getting buy-in, when we move to harvesting to shoreline, harvesting in riparian areas, putting in all the important things of minimizing the adverse effects that can happen, we really only got successful when we started telling the story of beaver. So we knew from our monitoring programs that beaver populations were down, and we had lots of good reasons to harvest the shoreline. It was an unnatural pattern, but being able to tell the story of providing young cereal stage forests next to the water, particularly smaller ponds, and selling that in terms of the beaver as the indicator was important. It was a means to achieve our end. Transparency and documentation. We went through great efforts in our last couple of guides. We have a guide for stand and site guide, largely about conserving biodiversity. A couple hundred pages long. There's a 600-page background and rationale document to go with it. And we were pretty blunt in there. We include statements like, when we're talking about watersheds, forest harvesting is very likely to increase the mobilization, off-site transport, and methylation of mercury. Because that's what the evidence told us. And here's how we've reacted to that. In that case, we don't actually have catchment direction, explicit catchment direction. Systems thinking, like this Bayesian belief network, getting to saying, here's how we think the world works, here's why we believe it's that way, and here's how our direction responds to that. So you can actually, as one person involved in one of our guide development processes who was a little fearful of this at the start said, you're giving our critics both the gun and the ammunition at the same time. And yeah, that's what we're doing. We're trying to do that on purpose. But we're also giving ourselves the ammunition to say, where are the difficult parts? Where are the highly sensitive parts of that model that we could actually improve on? What could we learn specifically? What would change our mind about direction? We could actually describe some of those things in advance. Collaboration is important. We're sneaking up on collaborative decision making. We're sneaking up on using some decision analysis techniques to solve some of these problems. Those tools can help get through some of these value problems. They don't make them go away, but they at least make them more obvious of where are you actually talking about values, where are you talking about technical differences. And we've learned the hard way many times, setting aside as much time as you think, doubling and then tripling that to tackle some of these values-based things first, or you're going to be forced to just ram them through. Sometimes we do that. And focus on conclusions, not differences. So taking from a decision analysis field of what is the actual, when you disagree on something, does it matter? Will you reach the same management conclusion, the same policy conclusion? You may have a different idea of the probability of success or the level of uncertainty of achieving that, but you may actually be able to agree on this policy is still the correct way to get there. And then as you disagree on the probability of success, maybe the monitoring has to be enhanced to support that. And then finally, hold your ground. So I think our experience in Ontario is this ecosystem-based management approach philosophy concept, it's worth continuing to work at. We're having a bit of a renaissance right now of individual species, featured species kind of protection through our evolving of endangered species management in particular, and trying to not push back, because they're still important, they're being recognized for a reason, trying to fit them as best we can into the mold, not losing the baby with the bathwater, as was said earlier. I put questions on my slide, but ignore that. We're waiting for the panel.
Thank you.